Also called stepped reckoner, this machine could add or subtract an 8-digit number to a 16-digit number, multiply two 8-digit numbers to get a 16-digit result, and divide the 16-digit number by an 8-digit divisor. Addition or subtraction is performed in a single step with a single turn of the crank. Multiplication and division are performed digit by digit on the multiplier or divisor digit, such as the process we follow in mental arithmetics. Leibniz invented this machine in 1672 and completed it in 1694. It was the first calculator that could perform all four arithmetic operations: addition, subtraction, multiplication, and division. Indeed, Leibniz had heard about Blaise Pascal calculator, the Pascaline, and simply concentrated on expanding Pascal's mechanism to multiplication and division. Actually, Leibniz didn't invent the calculator. However, it triggered what we can call a revolution in building a machine that could solve the four basic operations by the invention of the Leibniz wheel, the key piece of its machine. Despite of some mechanical issues that prevented some machines from working reliably, its calculating process inspired many other calculator builders for quite the 3 next centuries before the arrival of the electronic calculator. The machine performs multiplication by repeated addition and division by repeated subtraction. The basic operation performed is to add the operand number to the accumulator register as many times as desired by turning the operating crank in the clockwise direction. To subtract, the operating crank is simply turned in the opposite direction. The number of additions or subtractions is controlled by the multiplier dial. It operates like a telephone dial with 10 holes in its circumference numbered from 0 to 9. Thus, for example, a multiplication of a number of 5 digits by a number of 3 digits simply consists in a very long addition of the first operand of 5 digits, repeated the second operand times.
Good morning everyone! Today we're going to start a new chapter. So this is chapter number 5. Chapter number 5. The derivatives. So, first let's do some history.
Leibniz had a really concrete life. He studied philosophy, law, he was also a diplomat, and he's known as the biggest intellectual of Europe. Moreover, he studied mathematics. The main topic of his life in mathematics was the derivative. It's used to determine the slope of a tangent line of each point of a graph.
Salome, you don't already need to invent calculator. Yes, you. What?
What they did? Yes, that's right. It will help us to calculate faster. Yeah, if I could. Oh yes, a very simple mechanic process. Oh yeah, I found it. I'm ready. Yes, it works.
When Leibniz invented his calculator, it only computed simple operations. Indeed, it could calculate additions or multiplications. Whereas today, it guarantees the possibility to calculate difficult operations such as logarithm, exponential functions, sequences, etc. Moreover, calculators are much more efficient today. Indeed, they can draw graphs and compute instantaneously derivatives. We should consider it that without Leibniz and his inventions, such as the calculator, we couldn't have the possibility to understand math in easy way. So Leibniz played a really important part in mathematics history.
Derivative is used to determine the slope of a tangent line of each point of a graph.
Okay, that's it. I got it.
So, Leibniz characterized the sign by d squared y divided by dx squared is equal to minus y. When he studied the sine function, Leibniz had to choose a notation for the second derivative, which is the same as the actual notation. Also, thanks to him, nowadays we own the description of the line of the sine, and that discovery is really important because without it we couldn't study trigonometry as well as we do it today. So it's a major point in the mathematics history. Leibniz also worked on the exponential function. That's a really important work in his life. He's one of the first to put a variable for an exponent, which represents a major step in the study of the exponential function. And the exponential function is really important thing in the actual mathematics. So I think that because of those two discovery and the others that he did, we can say that Leibniz is a really important mathematician for the whole history of mathematics. I mean, he's not an important mathematician only to his age, but also nowadays, because he made really important discovery at his time, so that was important when he was alive, but we still use it today. So yeah, he's one of the best not one of the best, but one of the most important mathematician we ever knew. I think we could say that. Yeah. Thanks. Bye.
Voilà, là ça filme là. Hein.